Hello everyone. In this video I'm going to do examples. They are about the second order and linear and with constant coefficients. Okay, and the form goes this way, which let's write it first. A cannot be 0. A, B, and C are real numbers. These constant coefficients are real numbers. And in this case, or here, we're considering these external forces to be 0, or they are neglected. So that gives us the homogeneous form, which is this way. And now in this video, the examples are going to be about distinct. This video is distinct, or two distinct, of course, real solutions, not the complex ones, and here repeated root. Okay, so let's try the first one. And the auxiliary equation is this, which we know how to factor. And give us the two roots, and from there we just set up that general solution. And if you haven't seen the previous video, you probably want to watch it so you know how this got reduced and where this formed and all that information. Alright, so it doesn't mean your roots have to be like integers and this and that. Doesn't matter. So let's try, as long as they fit the profile, that's how you set up the general solution. So here for r squared plus r minus 2 equals 0. And if you just do the quadratic formula, you'll get the two roots to be -1 plus square root of 33 over 8. That means the general solution is C1 e2, let's say one of them, let's say this one, times t plus C2 e to, let's say, the second one. Okay. So now that we've seen this, we can maybe try an IVP. And we give it this initial conditions. And now it reduces to this also called characteristic equation. Which can be factored to this, and the solution combining the other two. Let's write this first. C1 with ER2 T plus C2 E2 R3T. Okay. We know we need the derivative, so let's go for it. And that's a C1 times a 2, and that's a C2 times a 3. Okay, so now let's use the first initial condition. Maybe do this in this first one, and that gives us C1. E, when you put T as 0, gives you 1, and same thing here, it gives you 1. So you get 1 equal to 1/5 from that one. Let's do the second one. Same thing happens here, and equals to -2. So here from you can choose to solve for C1 or C2 if you want to use substitution. Can also use elimination. Let's do this. So now this is gonna come here using substitution. C2, not that far. So 2C1 plus 3, C2 is -1/5 minus C1 equal to -2. Alright, so you know that you need to distribute, you know that you need to combine and try and all this, and you get C1 to be 7/5. So pause the video, try it, see if you get this, which leads to C2. Now going back to this one, you get -8/5. Okay. Alright, so we go back to that formula. We substitute C1 and we get back C2. So it's just kind of a sequence of steps. What's good about this differential equation, it's almost like you're running through the same concept when you solve these IVPs, as long as we know which methods applies to what. Alright, so we can now go ahead and just maybe we'll keep it same screen and say that y of t is C1 7/5 times e to 2t minus 8/5 times e to 3t. Okay, so now let's go for repeated roots. Yeah, let's do also as an IVP. So this kind of like reduces to this. It's a perfect square. Means we have a repeated root. And the setup for its form or general solution is we use C2 times e to t, which is the r. Yeah, so even though it's repeated root, the idea will run the same. We need to go ahead and find the first derivative because we need it for initial condition. As you notice, I will run into product rule in the second one, t times e to t there. So when you do the product rule, you'll get this. Then you distribute C2. Alright, so now we're ready. This goes here. And just like before, it will give us that, and now equals to 5. And this goes now here. And y prime of 0 will equal to c1 plus c2 plus 0 because t will pick up 0 there. And actually here we'll also, I should write it. I wanted to write it so it's clear. And I didn't write 0. But here it is. So that's what happens in repeated roots. It's same idea of e power 0 is 1. But let's make it show it in a better way. C2 times 0 equal 5 equal to, let's see, 27 over 4. Yeah. Alright, so this one gives me C1 equal 5. And now C2 is 27 over 4 minus 5. 5 is 5 times 420 over 4. So 27 over 4 minus 20 over 4, which is 7/4. Alright, so that gives us what we're looking for. And I haven't used this blue, so let's use it. I'm just going to stay consistent. C1 is 5 with ET, and C2, which let's write it here. After we found it, it's 7/4 plus 7/4 t et. Alright, that's the desired solution for this IVP. Okay, I'll do another video for linearly independent just to explore. And I think I'll usually at the beginning here for, let's say, a software or something for that, just to check whether the equations are linearly independent or not. Maybe I'll give you the raw skin as well there. Okay, thank you.